Right now, in July 2026, humanity is watching the final chapter of a story that began exactly 1 year ago. And it is a story real enough, strange enough, and significant enough that it needs no exaggeration at all. 3I Atlas, only the third interstellar object ever confirmed by astronomers, is on its way out, leaving our solar system forever, never to return, and in its final months of visibility, it has handed scientists some of the strangest, most genuinely unexpected data of the entire James Webb era. Let's start with the basics, because the real story here is dramatic enough without inventing anything. 3I Atlas was first spotted on July 1st, 2025, by the NASA-funded Atlas Survey Telescope in Rio Hurtado, Chile, a facility specifically built to scan the sky for exactly this kind of object. At the moment of discovery, it was roughly 410 million miles from the Sun, sitting within the orbit of Jupiter, moving on a trajectory that immediately told astronomers something important. This was not a local object. This was not an asteroid or comet born inside our solar system. This thing came from somewhere else, entirely flung across interstellar space from a different star system, drifting through the galaxy for what may be billions of years before it ever crossed paths with our Sun. It became only the third confirmed interstellar visitor in recorded history, following 1I Oumuamua in 2017 and 2I Borisov in 2019. From the very beginning, 3I Atlas demanded attention from every major observatory on Earth and in space. Hubble captured detailed images of it as early as July 21st, 2025, revealing a teardrop-shaped cocoon of dust surrounding a solid, icy nucleus, exactly what you'd expect from a genuine comet, just one that had traveled here from an entirely different corner of the galaxy. Based on those observations, astronomers estimated the upper limit of its nucleus at around 3.5 miles across, though it could be as small as roughly 1,400 feet, a huge range that itself tells you how much uncertainty surrounded this object, even in its earliest weeks of study. Then came the moment that made 3I Atlas impossible to ignore. On October 29th and 30, 2025, the comet reached perihelion, its closest approach to the Sun, passing just inside the orbit of Mars. For those first few critical days near the Sun, when the intense heat should have triggered the most dramatic activity of its entire visit, 3I Atlas effectively vanished from our view, passing almost directly behind the Sun, as seen from Earth, making direct observation from our planet temporarily impossible. Astrometric observations only resumed on October 31st, the moment it began emerging from behind our star. And when telescopes finally caught up with it again, what they found was not what anyone expected. Hubble's Wide Field Camera 3 captured something genuinely striking in mid-January 2026, an intricate structure of jets erupting from the comet's nucleus, 4 distinct streams visible in false color imaging, including a prominent anti-tail jet pointed directly back toward the Sun, along with 3 smaller jets spaced with an almost eerie geometric regularity, separated by exactly 120 degrees from one another. That anti-tail alone stretched out to roughly the distance between the Earth and the Moon. For a natural tumbling chunk of ancient ice and rock, that kind of structured, repeating jet pattern is unusual enough that it genuinely surprised the astronomers studying it before they worked out the physics behind it, tied to the comet's specific rotation and the way sunlight was heating different faces of its nucleus at different rates. And this is where the real mystery of 3I Atlas begins. Not with anything artificial, but with genuine, still unresolved questions about its chemistry, its age, and exactly what kind of environment it must have formed in. Questions astronomers are actively racing to answer before this object leaves our solar system forever, on a one-way trip back into the depths of interstellar space it came from. Because the deeper Webb looked into this comet in the months following perihelion, the stranger, and the more scientifically important, its story became. What NASA's most powerful telescope found hiding in this object's chemical signature would end up making global headlines, not because of any invented alien theory, but because of something far more scientifically fascinating. 3I Atlas turned out to be genuinely, measurably unlike anything astronomers had ever studied before, a fact confirmed not by speculation, but by peer-reviewed data published in one of the most respected scientific journals on Earth. The breakthrough came on June 22, 2026, just weeks ago, when a team led by astronomer Martin Cordner at NASA's Goddard Space Flight Center published a genuinely groundbreaking study in the journal Nature, using James Webb's NIR-SPEC instrument to analyze 3I Atlas in detail no interstellar object had ever received before. And the results immediately set the astronomy world talking, not because of anything artificial, but because of something almost as strange in its own way. This comet's chemistry simply did not match anything in our own solar system. Webb detected an unusually heavy ratio of deuterium, a rare, heavier form of hydrogen, locked inside the comet's water ice. That single detail matters enormously because the amount of deuterium enrichment in cometary ice is essentially a chemical fingerprint of the exact temperature conditions the object formed in billions of years ago around a star that isn't our sun. According to Cordner's team, producing that level of heavy water requires an environment colder than roughly 30 degrees above absolute zero, negative 406 degrees Fahrenheit. Brutally, almost unimaginably cold. As Cordner himself put it in the published findings, this is an object that doesn't seem to match our own solar system, our own comets. It doesn't match nearby protostars either. This is something new and different. Then, in early June 2026, Webb's mid-infrared instrument delivered an even bigger surprise. During two separate observation windows, one in mid-December 2025 and another at the end of that same month, as the comet traveled back out of the solar system after its swing around the sun, Webb detected something that had never been directly measured on any interstellar object before: methane gas streaming outward from the comet's nucleus in significant quantities, alongside carbon dioxide and vast plumes of water vapor vaporizing off icy grains suspended in the coma at large distances from the comet's core. The amount of methane relative to water was notably larger than what's typically seen in comets that actually formed inside our own solar system. Another clear sign that whatever star system 3I Atlas originally formed around, it operated under chemical rules meaningfully different from our own cosmic neighborhood. And then, just weeks later, an entirely separate research team added another layer to the mystery. Using Japan's Subaru telescope on January 7, 2026, more than 2 months after perihelion, astronomer Yoshiharu Shinaka and colleagues at the Koyama Space Science Institute measured the ratio of carbon dioxide to water in the comet's coma and found something that directly contradicted earlier measurements taken by Webb and NASA's SPHEREx Space Telescope. The carbon dioxide to water ratio calculated from the Subaru data came out noticeably lower than what those earlier space-based observations had suggested, indicating that the comet's actual composition may have been shifting, changing in real time as it heated up during its closest approach to the sun. In other words, 3I Atlas is not a static, unchanging lump of ancient ice. It is a genuinely active, evolving object, one whose composition is still surprising the scientists studying it months after its closest brush with our star. Put all of that together, and you start to understand exactly why this object captured such intense global attention throughout 2025 and into 2026. An object with heavy water chemistry, pointing to formation in extreme cold, methane levels unlike anything in our solar system, and a shifting carbon dioxide signature that doesn't match earlier predictions, all wrapped inside a nucleus that arrived from a completely different star system, one we will likely never identify with certainty. Every single one of these findings is genuinely significant, genuinely surprising, and genuinely capable of reshaping how astronomers think about how icy planetesimals form in protoplanetary disks around other stars entirely. It's also worth being honest about something else, because it says a lot about how seriously scientists took the more sensational claims that inevitably followed an object this strange. Given the object's unusual size, estimates, its structured jet patterns, and its unfamiliar chemistry, it was probably inevitable that conspiracy theories would follow, and they did, almost immediately, drawing comparisons to the earlier speculation that surrounded Oumuamua back in 2017. But this time, the scientific response was swift and thorough. A comprehensive SETI search specifically targeting 3I Atlas found 0 radio technosignatures of any kind, no artificial transmissions, no structured signals, nothing beyond what you'd expect from a natural, if genuinely unusual, comet. NASA and the broader international astronomy community have been consistent and clear on this point throughout. 3I Atlas is a natural interstellar comet, and its strange chemical fingerprint is fully explained by natural thermal outgassing, not anything artificial. The mystery here was never about aliens. It was always about something almost as remarkable, and ancient, genuinely alien chemistry formed around a star we'll never see, now vanishing back into the dark forever. While the chemistry data was making headlines in scientific journals, something else about 3I Atlas was quietly playing out that mattered just as much to how this story unfolded, its trajectory through our solar system, and exactly how close this ancient interstellar visitor was ever going to get to us. Because for a few tense weeks in late 2025 and early 2026, before the full trajectory calculations were locked in and widely publicized, this was a genuine question people around the world were asking, and it deserves a clear, factual answer. 3I Atlas never posed any threat to Earth, and the numbers back that up completely. At its absolute closest, the comet came no nearer to our planet than approximately 1.8 astronomical units, roughly 170 million miles, or about 270 million kilometers. To put that in perspective, that's nearly twice the distance between the Earth and the Sun. NASA planetary defense scientists confirmed this repeatedly throughout the comet's journey, and it's worth saying plainly, because in an environment full of dramatic headlines, this one detail is the most reassuring, verified fact in the entire story. Earth was never at any point in the comet's path. But that safe distance didn't make the comet any less scientifically valuable, and NASA didn't waste the opportunity. Throughout early 2026, the space agency coordinated an extraordinary multi-instrument observation campaign, pulling in Hubble, Webb, and NASA's TSS spacecraft, the Transiting Exoplanet Survey Satellite, which isn't even designed primarily to study comets, but was repurposed for a remarkable 28-hour continuous observation run of 3I Atlas between January 15th and January 22nd, 2026. That kind of sustained, dedicated observation time on a single object, using a spacecraft built for an entirely different purpose, tells you exactly how seriously the scientific community treated this object's significance. You don't reroute a planet-hunting satellite for a week straight unless what you're looking at genuinely matters. Hubble contributed one of the most visually striking data sets of the entire mission on January 22, 2026, capturing the comet during a rare near-opposition alignment when 3I Atlas lined up within just 0.69 degrees of the direct Sun-Earth axis, an unusual geometric coincidence that gave astronomers an especially clean, well-lit view of the comet's structure at a critical moment in its post-perihelion journey. Around the same period, Gianluca Massi's Virtual Telescope project and Gemini South Observatory in Chile captured the comet's tail actively developing and lengthening as it raced away from the sun, exactly the kind of behavior astronomers expect from a genuine, actively outgassing comet, responding to solar heating exactly the way physics predicts, just with a chemical signature nobody had cataloged before. By March 16, 2026, 3I Atlas made its next milestone, passing by Jupiter on its outward journey, continuing along the same hyperbolic trajectory that has defined its entire visit to our solar system, a path so extreme, so clearly unbound by our sun's gravity, that astronomers knew from the very earliest tracking data that this object was never going to settle into orbit here. It arrived from interstellar space, and it was always going to return to interstellar space, carrying with it, permanently, whatever chemical secrets it picked up on its long, cold journey between the stars. That brings us to now, July 2026, and the reason this story has resurfaced with such intensity in recent weeks. As of this month, 3I Atlas is officially on its final escape trajectory, moving steadily away from the Sun, away from Earth, and away from every telescope currently capable of studying it. Astronomers have a genuinely limited window left, likely only a matter of months before this object becomes too faint, too distant, and too small for even Webb's extraordinary infrared sensitivity to keep collecting meaningful data. Every single observation being made right now, every spectrum, every image, every measurement of its shrinking coma and fading jets may be among the very last data humanity ever collects on this specific comet, this specific piece of another solar system, before it disappears back into the vast dark it came from, quite possibly forever. That is precisely why every image Webb captures of 3I Atlas in these final weeks carries so much weight right now. Not because of any manufactured mystery, but because of a much simpler, more human truth. We are watching a genuine visitor from another star system make its final approach toward the edge of our own cosmic neighborhood. And once it crosses back out into interstellar space, the odds of ever studying this exact object again in this much detail are functionally zero. Whatever Webb captures next may be the last clear look humanity ever gets. So what happens next, and why does this final stretch matter so much to the scientists who have spent the last year studying this object? The honest answer is that 3I Atlas's disappearance marks the closing of a genuinely unrepeatable scientific opportunity, and researchers around the world are racing against the clock to extract every last piece of data before that window closes for good. Here's what makes the timing so significant right now in the second half of 2026. Unlike a planet or a star, which we can return to study again and again for as long as we want, an interstellar object like 3I Atlas is, by definition, a one-time event. It formed around a star we will likely never identify, traveled through the emptiness between star systems for what could be hundreds of millions or even billions of years, briefly intersected our solar system by pure chance, and is now leaving permanently on a trajectory that will carry it back out into that same interstellar darkness, never to return. We got exactly one chance to study this specific piece of another solar system up close, and that chance is measured in months, not years. Every image, every spectrum, every measurement Webb takes now is effectively irreplaceable. a final closing entry in a scientific record that can never be added to again once the comet fades beyond detection. That's exactly why the research hasn't slowed down, even as the comet grows fainter by the week. Scientists are still actively working to reconcile the conflicting carbon dioxide measurements between Webb, Sphere-X, and the Subaru telescope, still analyzing whether the comet's chemistry genuinely shifted as it moved away from the sun, or whether different instruments were simply sampling different parts of an incredibly complex asymmetric coma. They're still working to understand exactly what conditions, cold enough to produce that heavy deuterium signature, chemically active enough to release that much methane, could have shaped an object like this around a star that isn't our own. And they're still working urgently to capture as much high-resolution data as physically possible before 3i Atlas shrinks past the point, where even James Webb's extraordinary sensitivity can pull a usable signal out of the noise. Martin Cordner, the researcher who led the groundbreaking nature study back in June, has been especially direct about why this kind of research matters, far beyond just satisfying curiosity about one strange comet. Interstellar comets coming from different stars give us the opportunity to reach out across space and time through the galaxy, to study close up the planet-forming regions of other star systems. Think about what that actually means. We cannot travel to another star system. We cannot send a probe to physically sample the protoplanetary disk that surrounded some distant, unnamed star billions of years ago. But when an object like 3i Atlas drifts through our own solar system, however briefly, it hands us a genuine physical sample of that distant alien chemistry delivered directly to our own telescopes, free of charge, purely by cosmic coincidence. That's not science fiction. That's one of the most remarkable, quietly profound opportunities modern astronomy has ever had. And there's something worth sitting with in the fact that this entire genuinely historic scientific event unfolded almost exactly the way real discoveries usually do, not with a single dramatic reveal, but with a slow, careful accumulation of evidence, published in peer-reviewed journals, cross-checked by multiple independent observatories, openly debated in the scientific literature when different instruments produced conflicting numbers, and ultimately explained through solid, verifiable physics rather than speculation. Along the way, plenty of more sensational claims tried to attach themselves to. This story, and every single one of them, was tested and ruled out through actual data, not dismissed by decree. That process, unglamorous as it sounds compared to headlines about alien probes, is exactly what makes the real findings so much more remarkable. A comet formed in conditions colder than almost anything in our own solar system carrying chemistry, unlike anything we've measured before. Confirmed through rigorous, independent, published science, that's not a lesser story than the conspiracy version. It's a far more extraordinary one, because every part of it is true. So here's the question worth sitting with as 3i Atlas makes its final fading approach out of our solar system this year. Somewhere out there, right now, drifting silently through the vast emptiness between stars, there are almost certainly more interstellar visitors like this one, objects formed around stars we'll never see, carrying chemical fingerprints from planetary systems we'll never visit, waiting for the rare, random chance to drift close enough to our own telescopes to be noticed at all. Oumuamua came and went in 2017. Borisov followed in 2019. 3i Atlas arrived in 2025, and by the time you're watching this, it's already fading from view, heading back out into the dark for good. The real question isn't whether something artificial was ever hiding inside this comet. It's simple. What's the next one going to look like? And will our telescopes be ready when it arrives? Drop your thoughts in the comments below. And if you want to be here the moment astronomers announce the very last confirmed image of 3i Atlas before it vanishes from view forever, subscribe now, because this quiet, genuinely historic goodbye is happening in real time, and it won't happen again in any of our lifetimes.